Hello and welcome to part 2 in my Inequalities series. In the first video, if you haven't watched it already, I'd go back and watch it, is regarding how to draw an inequality on a number line and find integer solutions. Remember, an integer is a whole number. Now, to introduce you to my second part, which is on solving inequalities, I'm going to use a very useful diagram to explain why we treat inequalities slightly differently to equalities. So, if we take the inequality I have here, 4 is definitely less than 7. Now, what we're going to do to it is add or subtract or multiply or divide different things on both sides. So, if we take the 4 and we add 4 to it, we get 8. And if we do the same to the other side, 7 plus 4 is 11. And I think we could all agree that 8 is definitely smaller than 11. Okay, let's have a go at another one. If we try times by 4, well, 4 times 4 is 16, and 7 times 4 is 28. And I think we agree that 16 is less than 28. So I'd like you to do the same with each of the different arrows and see what you find out about the inequalities, where they change, if they change, and why do they change. Okay, so let's go through the answers. So this is -1, and that is certainly less than 2, so that's normal. This one here, for you people again that love decimals, this will be 1.3. Recurring is less than 7 divided by 3, which is 2.3. Recurring, also true. If we take this one over here, we get -5, and that is definitely going to be less than -2. If you get a bit confused on why -5 is less than -2, even though it seems like a bigger number, always think of it in terms of temperature. So think about which one is colder. And if you're out in -5 degrees, it's definitely going to be colder than -2 degrees. Okay, our next one down here, 4 minus -8, well, 2 minuses make a plus, so we get 12, and 7 minus -8, that will equal 15, and again 12 is definitely less than 15. Let's look at our next example over here. So 4 times -7, that will be -28. Remember, a plus times a minus is a minus. Likewise, 7 times -7 is -49. However, -49 is far colder than -28. So in this case, -28 is greater than -49. So notice in this situation, we actually switch the less than to a greater than sign. And let's look at our last example. So 4 divided by -2, well, a plus divided by a minus is a minus, so that becomes -2. 7 divided by -2 is -3.5. And again, we can obviously see that -2, well, that's going to be greater than -3.5. Again, think of it in terms of temperature. Which one is colder? So notice here actually that pretty much the inequality symbol stays the same, apart from in these two situations, when we divide by a negative number or multiply by a negative number. And that's the key point in today's part 2 video, that if you divide or multiply by a negative number, when you're solving an inequality, it switches the sign. So it switches from a less than to a greater than, or a greater than to a less than. So just to reiterate and reflect on what I just said, again, if you add or subtract on both sides of the inequality, or multiply or divide by positive numbers, then you leave the sign as it is. You keep it as a less than sign, or a less than or equal to sign. However, if you multiply by a negative number on both sides, or you divide by a negative number on both sides, that reverses the sign. It switches over the less than sign to a greater than sign, or a less than or equal sign to a greater than or equal sign. So let's go about actually solving these inequalities. Again, we approach it in the same way we would approach an equation. That is to get x on its own and bring all the x's to one side. So have a think for the first question here. What would one of my first steps be? Okay, so you should be minusing x on both sides. Now if you plus 8 instead, that's absolutely fine. We're just going to do it in a slightly different order. But I'm going to minus x on both sides. Remember, the opposite of plus x is minus x. We do the opposite of what you see there. So 3x minus x, well, that equals 2x. The minus 8 stays the same. We haven't minused any numbers or added any numbers yet. Is less than or equal to 30, stays the same. That hasn't changed. And the crucial part here, the plus x cancels with the minus x, and you're left with just 30. Now, what we're going to do is, again, we want x on its own. So how can we remove the minus 8? Well, we add 8 on both sides. So again, we draw our arrows, plus 8 on this side, and plus 8 on this side. Then that gives us 2x, that hasn't changed. Remember, x's and numbers are different things. Plus 8 and minus 8, they cancel. And then 30 plus 8 is 38. Notice all we've done so far is we've subtracted x on both sides and we've added 8. So therefore, we don't need to switch the sign. Likewise, to remove the times by 2, we do the opposite. Remember, 2x is 2 times x. So the opposite of timesing by 2 is dividing by 2 on both sides. That has the effect of cancelling the 2 and 2, giving us the answer x is less than or equal to 19. And that's our final answer. Okay, so we've just followed the steps. Again, we've looked at our lists. We've only added, subtracted and multiplied by positive numbers. Therefore, we don't have to switch the sign. However, it can be slightly different. So I'm going to approach the second question in a slightly different way, perhaps than some of you might do, but to show a very important point. Now, my first step is to minus 10 on both sides. Remember, the 10 is a plus 10. The minus refers to the 3x. This is a plus 10, even though we don't write the plus. So we have to minus 10 from both sides. If we do that, we get minus 3x is less than, well, 30 minus 10, that's 20. If you want to think about it, the 10 cancels the minus 10 here. And we still have the plus 2x, that hasn't changed. Now we want all the x's on one side, so if we do the opposite of plus 2x, which is minus 2x, on both sides, again we draw our arrows nice and clearly. So minus 3x minus 2x, well, the minuses are separate, so we use our number line like temperature. If it's minus 3 degrees outside, it gets 2 degrees colder, then it will be minus 5 degrees, minus 5x. So be very careful. One of the biggest mistakes that are made with these questions is a lot of people think, two minuses make a plus, it must be minus 1. It's not the case. The minuses are separate from each other. So think of it like temperature. So minus 5x, well, that's less than 20, stays the same, that doesn't change. Plus 2x cancels with the minus 2x, and we're left with this inequality. Now we want to remove the minus 5. So the opposite of timesing by minus 5 is dividing by minus 5. Again, we do the same to both sides. That's important. Now again, the minus 5 cancels with this 5, leaving us just x. And remember, we have divided by a negative number. I will highlight this. Divided by a negative number. And if we do this in any step of our inequality, then that reverses the sign. So we change this to a greater than sign. That's a really important point, that apart from this mistake up here with minus 3, minus 2, is also a very common mistake that people forget to reverse the sign. They think of it too much like an equation. And just to finish off our inequality, 20 divided by minus 5, that will then be minus 4, and we are done. Now sometimes GCSE and iGCSE questions will then ask you to actually draw that on a number line. If you're not sure how to do that, then look at part 1 of the video. That will show you what you need to do there using an open and closed circle. Okay, so that is the main way we solve linear inequalities. So have a look at my next slide. So questions 1 to 12. Have a go at those questions. I'd say take no more than 10 minutes just to get some familiarity with using the inequality signs. Now, as usual in my videos, I'll always do the first one with you. So question 1, x minus 3 is greater than 10. So we want to get x on its own. So what's the opposite of minus 3? Well, that's plus 3 on both sides. Remember, it's like a scale, you have to do it on both sides to keep the balance. Therefore, the plus 3 cancels with the minus 3. We're left with x is greater than 10 plus 3. That then gives us 13. So, have a go at those questions. Again, pause the video, take about 10 minutes to have a go at those questions, and then we'll go on to the next slide. Okay, hopefully you didn't find those too difficult. So let's have a look at some slightly different examples. So I'm going to have a look at question 21. Of course, feel free to have a go at question 13 to 20. They're very similar to the questions you just did, but again, just watch out for a few little tricks there. Now, in this question, the height of this picture has to be greater than the width. Find the range of possible values of x. This is one of those confusing worded questions that doesn't really give you anything to grasp or hold on to. Now, the key thing is to use the information in the question. We know what the height is. That's 2 brackets x plus 1. So we write that down, 2 brackets x plus 1. This is question 21, by the way. Okay, and we're told it's greater than the width, so we literally follow it linearly. We've written the height of the picture, then we put the greater than sign, remember, no line underneath, and then we put the width, which is x plus 7. So now we've turned it into a question that we've seen in the previous 20 questions. Again, we need to work through it nice and steadily. The first step is to expand the brackets by using what I like to call the hook. So let's use our hook 2 times x, well that's 2x. 2 times 1 is 2. Again, there's no need to rush these questions. Just take it one step at a time. Okay, and then we want to get the x's on one side. So what's the opposite of x? Well, that's minus x. So we minus x from both sides. That then gives us 2x minus x. That's x. The plus 2 stays the same. Greater than, again, we've only minus from both sides. No need to switch the sign. X and minus x cancel. We're left with 7. And then a step you already did in the first question. You need to minus 2 then from both sides to give us x is greater than 5. And we're done. So don't let these worded questions confuse you. Again, just work through it logically, write down your height, use the correct mathematical symbol, in this case a greater than sign, and then follow it through it logically like the previous questions you just did. So have a go at these questions if you haven't already done so, and just pause the video and give yourself again about 5 minutes to have a go at these. Okay, so our final slide for today is to look at combined inequalities. What that means is when you have two inequalities in the question. So if we look at question 22, we've got a less than or equal symbol and a less than or equal symbol. So the best way to approach these is to treat it as two separate inequalities and then combine the answers at the end. What do I mean by this? Well, let's take the first half of the inequality. So that is 10 is less than 2x. And again, to make it a bit simpler for us, we like to have x on the left-hand side. So 2x is greater than or equal to 10. If you're flipping these two things over, you need to make sure the greater than sign is correct there as well. And again, what's the opposite of timesing by 2? Well, that's dividing by 2 on both sides. That, if that cancels with that, gives us x is greater than or equal to 5. Okay, and now we approach the second half of the inequality. That is, we look at the second half here. So we write that down. This way, it's actually in the right order for us, so it makes our life a bit easier. So 2x is less than or equal to x plus 9. And we solve it in the similar way we've done in the previous two slides. So we minus x from both sides. We want all the x's on one side. 2x minus x is x. Less than or equal sign stays the same. X cancels with minus x, so x is less than or equal to 9. So our final answer, we're going to combine the inequalities. So we're told here that x is greater than or equal to 5, but x is less than or equal to 9. So if we reverse this around, 5 is then less than or equal to x. So all I've done is I've taken this inequality and reversed it around, and then I bring this part of the inequality and pop it down here. So less than or equal to 9. And that makes sense, because if we go back to our first video, the part 1, and I ask you, well, what can x be? You would tell me that if x is greater than or equal to 5, but less than or equal to 9, well, the only values x can be are 5, 6, 7, 8, and 9, in order to satisfy, to work with the two inequalities. And if we look at our final answer, Well, x is 5, 6, 7, 8 or 9. Those are the only answers that make sense. So always do a common sense check to make sure your inequalities are facing in the right direction. Okay, so to finish off for today's part 2, have a go through the answers. So this is the answers to the last 3 slides that you've just seen. So I've collected all the answers there for you so you can mark your work. Again, marking your work is really important. If you're getting an answer incorrect for some reason, then go back through the video, look at the examples that I have done. One thing to be aware of course, is that sometimes the answers are written as fractions. So if you got x is less than or equal to 2.5 or x is less than 0.25, then that's absolutely fine as well. In fact, on the mark scheme for iGCSE Cambridge, which is the exam board I prepare my students for, you'll see there are 2 letters called OE. Write those down, OE. Now that stands for or equivalent. So if you put a decimal answer or a fraction answer, sometimes even a percentage answer that means the same thing, then that's absolutely fine. You don't lose a mark and you get the full marks for the answer. So that's the end of part 2 on solving linear inequalities. In part 3, I will look at graphically representing inequalities and finding the correct region. Quite a popular question at GCSE, less so iGCSE Cambridge. It has come up about 5-6 years ago, hasn't come up very recently, but again, it's on the scheme of learning for iGCSE, so it's a topic you need to master. So I hope you found this video interesting. Again, please like, please subscribe, please share with your friends. If they want to listen to me talking about inequalities or any other topic, then please let me know if there's any other topic you would like me to go through. Okay, thank you. Bye bye for now.